Welcome to Spring LIB.
So here we have a gyroscope and we have a rotor which is spinning along this path, and the rotor is rotating along this direction. We call this omega, which is the angular velocity for the rotor, and for this precession velocity we call that big omega. So now if we want to figure out the upward force exerted by the pivot, we'll see that this rotor has a mass, and the gravitational force is acting downwards. So, and since the rotor is not going down, it's balanced. So that means through the pivot point, there will be an equal and opposite force which will be balancing this mg, or the weight of the rotor. So that means um, the force acting on the pivot point will be, let's say, Fp, which is equal to the weight of the rotor, or let's call the total weight, which is 0.165 kg times 9.8 meter per second squared, which gives us 1.62 Newton. Now in part B, we need to find out this omega quantity right here. So we know that precession velocity, or precession angular velocity, omega, is equal to weight times r. R is the radius, divided by I over omega, where I is the moment of inertia. Now, we don't know the omega. We need to figure out that from the problem. So in the problem, it says that the gyroscope is precessing in a horizontal plane at a rate of 1 rev in 2.2 seconds. So omega will be 2 pi radians per 2.2 seconds, which is 2.856 radians per second. Now we can solve for this omega, or the little omega, which is W times R over I times big omega, and we know all the values. So this W is 0.165 kg times 9.8 meter per second squared times R, which is 0.4 meter, divided by I, is given as 1.2 times 10 to the power minus 4 kg meter squared times omega, or big omega, which is 2.856 radians per second. And that gives us our little omega as 189 radians per second, or 1.8 times 10 to the power 3 revs per minute. Now for part C, we can actually explain part C in this diagram. So if we um, look at the figure from above, we'll see that torque will be in the direction of the precession. So this is the precession velocity. So torque will be, so let me actually draw it here. So we have the rotor around here, and then it's rotating along this axis. So the torque, if we look from above, the torque will be along in the direction of the precession. So maybe the like tangential direction at each point. And then for L, this will be along the axis of the rotor away from the pivot point. So if this is the pivot point, then L will be directing this way. So this is torque, this is L, which will be away from the pivot point, and it will be along the axis of the rotor. So the rotor is spinning like this, so that means the axis is this way. So that's why L will be away from the pivot point. Thank you.